Okay, so in the previous video we looked at this dataset for HMDA. We applied tidyverse and we did some exploratory data analysis with a relatively open mind, considering a range of the different predictors. So we looked at the debt to income or debt service to income ratio, housing expense to income ratio, CCS, the credit score, the mortgage credit score, and so on, and also the relevance or how significant race was perhaps in interacting with those variables, how it influenced was a mortgage approved or not. Again, the genesis of this paper is Varian 2014. A number of the techniques that are developed by Hal in the Journal of Economic Perspectives for machine learning are applied to the Titanic dataset that can be obtained from Kaggle. And then subsequently he went on and applied the same techniques to HMDA, and in particular he took a look at the Munnell et al. 1996 paper, and there's some interesting review of that from LAD 1998. But in summary, we can go directly to the Federal Reserve of Boston. They have a reference. They originally, that paper, by Munnell et al. 1996, that was published in the American Economic Review, that originally went in as a working paper and then was revised to take on board some critiques that were offered. But their basic result was, the results of this study indicate that minority applicants on average do have higher debt burdens, higher loan-to-value ratios, weaker credit histories, and they are less likely to buy single-family homes than white applicants. And these disadvantages do account for a large portion of the difference in denial rates, including the additional information on applicant and property characteristics, reduced the disparity between minority and white denials from originally reported 2.7 to 1 to roughly 1.6 to 1. But these factors do not wholly eliminate the disparity, since the adjusted ratio implies that even after controlling for financial, employment, neighborhood characteristics, Black and Hispanic mortgage applicants in the Boston metropolitan area are roughly 60% more likely to be turned down than whites. Again, the date is, a publication of this is 1996, so this is historical data, and the data set goes back to 1990. This discrepancy means that the minority applicants with the same economic and property characteristics as white applicants would experience a denial rate of 17% rather than the actual denial rate of 11%. Thus, in the end, a statistically significant gap remains, which is associated with race. The information gathered in this survey provides some insights on how this outcome emerges. Many observers believe that no rational lender would turn down a perfectly good application simply because the applicant is a member of a minority group. The result of this survey confirmed this perception. Minorities with unblemished credentials are 97% certain of being approved, but the majority of borrowers, both white and minority, are not perfect, and lenders have considerable discretion over the extent to which they consider these imperfections as well as compensating factors. So it's fairly clear here this is highly nuanced, and there are of course many factors that are at play, and of course a lot of the issues that are addressed are highly controversial, and even to this day race is a highly controversial topic in the United States. And when we measure different outcomes and life expectancy and wealth distribution, there are very forthright plain to see differences between different segments of the population. Also, issues that arise here are related to what is discrimination. Of course, it's when we look at data like this, then it's worth bringing on board additional statistical type analyses. Now, we will use here the analysis offered by, and the scripts, our scripts in particular, offered by Varian. So again, the Journal of Economic Perspectives, 2014, Big Data New Tricks for Econometrics. And he sets out here in the economic analysis, in the statistical analysis that he applies to the HMDA data, he has some interesting findings. We might just read a little bit what he does here. So Munnell et al. 1996 examined mortgage lending in Boston to see if race played a significant role in determining who was approved for a mortgage. The primary econometric technique was logistic regression, where race was included as one of the predictors. The coefficient on race showed a statistically significant negative impact on probability of getting a mortgage for black applicants. This finding prompted considerable subsequent debate and discussion. See LAD 1998. Okay, so on page 49, okay, so that's evidence on discrimination in mortgage lending, Helen Ladd, and on page 49, just at the bottom, she explains a little bit the background to the HMDA, which is quite a good review, that paper as well, so that's something of interest. And then the variables incorporated into the Boston Federal Reserve Bank study. Now, the ones that we use and are available in the ECDAT library in our studio and also in the AER library in our studio, we only have 13 of the 12 predictor variables, so it's a little bit reduced, and we only have 2,380 observations. But again, it's kind of interesting. Varian's results here are developed from, he applies a couple of techniques, C-trees, logistic regression, and random forest. The conclusions that he develops from those are probably worth noting here. Here I examined the same question in terms of race and discrimination using a tree-based estimators described in the previous section. So that's the C tree, the conditional inference tree that's available in the party package. So the data consists of 2,380 observations of 12 predictors, one of which was race. Figure 5 shows a conditional tree. So that's what's in, we'll generate this also. So this is a conditional tree from the party package invoking C-tree function, and it shows a conditional tree estimated using the R party package. For reasons of space, I've omitted variable descriptions are readily available in online supplements. So we have those in the code, in the script, and we've discussed already a little bit. The tree fits in our exploratory data analysis. We've gone through the different predictors. The tree fits pretty well, misclassifying 228 of 2,380 observations for an error rate of 9.6. By comparison, a simple logistic regression does slightly better, misclassifying 225 of the 2,380 observations, leading to an error rate of 9.5. As you can see in figure 5, the most important variable is DMI, denied mortgage insurance. This variable alone explains much of the variation in the data. The race variable, black, shows up far down the tree and seems to be relatively unimportant. Okay, so again, this is not quite consistent with the what we would have taken from the American Economic Review. If we look at that the findings of the original authors, Munnell et al. 1996, I think they're saying it's still quite significant that the race is associated with quite a degree of discrimination. Again, this is a different perspective that's been developed, and it's based on, in this instance, the C tree. So the race variable shows up far down the tree and seems to be relatively unimportant. One way to gauge whether a variable is important is to exclude it from the prediction and see what happens. When this is done, it turns out that the accuracy of the tree-based model doesn't change at all. Exactly the same cases are misclassified. Of course, it is perfectly possible that there was racial discrimination elsewhere in the mortgage process, or that some of the variables included are highly correlated with race, but it's noteworthy that the tree model produced by standard procedures that omits race fits the observed data just as well as the model that includes race. Okay, so in the next video, I'm going to take a closer look here at the scripts. See, in addition to, if we go back into the Journal of Economic Perspectives, we have the original code here in the data sets, and if we drill down a little bit into the files here, if we download this, we can see that there are files here that we can use, and scripts we can use here to apply Hall's analysis ourselves. So I download that, and in the next video we'll take a look at the C-tree implementation suggested by Varian. We'll take a look at the logistic regression and a technique to drop the variables, different predictors, and we'll take a look at the random forest techniques suggested by Varian in his paper, and we'll, as much as possible, try to replicate the results that are obtained here, and then consider, okay, how does this differ from the original Munnell et al. Study, and also we probably need to bear in mind that the other predictor variables are highly correlated with race, and that also has a bearing here. And again, the evidence, the statistical evidence here is very nuanced, and it also suggests not only should we be familiar with the different statistical tests and techniques, machine learning, logistic regression, so on, it also is of importance to be somewhat of a domain expert when trying to parse through the findings and the evidence and the conclusions that might be suggested by any particular statistical techniques. Statistical techniques like the C-tree are very powerful visual aids, but as explained by Hal here, the black variable comes way down the set of nodes. It's node 15, and it's only having a marginal effect here in a limited subset of the entire 2,380 applicants, and that's not completely consistent with the findings of Munnell et al., who would identify race as being a more prominent predictor and more significant predictor, and that there was evidence of discrimination based on race. Okay, so in the next video we'll go through the script in RStudio Cloud, and we'll try to replicate the results obtained here in the paper.